Teen births in relation to women's education.
Why did we choose these variables? We chose these variables because analyzing and finding relationships between them bring us one step closer to solving some of the world's largest and most important problems, outlined by the United Nations.
The United Nations Sustainable Goals are interlinked global goals designed to achieve a more sustainable future for all. The fourth goal is having a quality education, and the data of average education for girls aligns with this goal. By reducing the scope of the education variable to specifically women, we can analyze how countries are educating their females, which aligns with the fifth goal of gender equality. According to NCSL, the first goal, eliminating poverty, is heavily linked to the lack of education and teen births in women. Through finding relationships with different variables, the problems at hand can be better understood. If we solve the problem of lack of education in women, we can solve many of the United Nations goals. Moreover, through discovering cause and effect relationships, independent variables can be influenced to reach the United Nations goals. The hypothesis that we came up with was that higher mean years in school for women ages 15 to 24 will directly correlate with a lower teen fertility rate. Within this hypothesis, the independent variable is the years of education for women. By investigating the amount of education, we can find a potential cause for teen pregnancy, and according to the National Library of Medicine, a longer and better education may provide women with other ambitions, such as starting a career and understanding the use of contraceptives, which can delay pregnancy. This variable will be measured in mean years in school of women ages 15 to 24, and this age group was specifically chosen as this is the time where women start to decide their future as an adult. The dependent variable is the teen fertility rate. Through analyzing the fertility rate, we can see the effect of women's education. The teen fertility rate is measured in births per 1,000 women ages 15 to 19. With the one variable statistics, the independent variable, years in school for women, looking at the measures of central tendencies, the mean is at 9.5 years of school for women, while the median and mode are higher at 10.4 and 10.3 years of school respectively. Since the mode and median are higher than the mean, the data creates a left-skewed histogram. When looking at the histogram, it is clear that there are more countries with a higher education than countries with a lower education, and this creates a left-skewed histogram. Since this is a left skew, the mean is affected the most by lower data points, making the median the best measurement of central tendency for this dataset. Additionally, since the graph is not normally distributed, the estimates using the standard deviation will be off. However, the standard deviation 3.25 years in school is a useful calculation when comparing this value to other years to see how the spread changes annually. With the quartiles and the cat and whisker plot, it is evident that the data is spread out much more below the IQR than above. Secondly, quartile 1, at 6.995 years in school, is the median of the bottom 50% of the data, and quartile 3, 12.05 years in school, is the median of the upper 50%. When comparing this to Canada, Canada averages about 14 years of school for women, 2 years above quartile 3, showing how Canada is in the top 25% of countries. This also corresponds with Canada being 1.37 standard deviations above the mean and is at the 97th percentile, as Canada has more schooling for women than 97% of countries. This dataset also has no outliers, showing that there are no extreme data points. And the one variable statistics for the dependent variable, teen fertility rate, through looking at the measures of central tendencies, the mean is at 50.38 births per 1,000 women, while the median is lower at 38.2 births. Since the median is lower than the mean, the data creates a right-skewed histogram. Looking at the histogram, it is clear that there are less countries with a higher teen fertility rate than countries with a lower teen fertility rate, creating a right-skewed histogram. Since this is a right skew, the mean is affected the most by the higher data points, making the median the best measurement of central tendency for this dataset. Additionally, since the graph is not normally distributed, the estimates using the standard deviation will be off. However, the standard deviation of 41.54 births per 1,000 women from ages 15 to 19 is a useful calculation when comparing the value to other years to see how the spread changes annually. With the quartiles and the cat and whisker plot, it is evident that the data is spread out much more above the IQR than below. Secondly, the quartile 1, 15.6 births per 1,000 women from ages 15 to 19, is the median of the bottom 50% of the data, and quartile 3, 72.65 births, is the median of the upper 50%. When comparing this to Canada, Canada averages 12.3 births per 1,000 women from ages 15 to 19, about 3 births less than quartile 1, showing how Canada is in the bottom 25%. This also corresponds with Canada being 0.917 standard deviations away from the mean and is at the 18th percentile, as Canada has lower teen fertility rate than 82% of countries. This dataset also has 3 outliers, all being above the upper outlier boundary. An interesting thing to note is that all 3 outliers, Niger, Democratic Republic of the Congo, and Mali, are all countries located in Africa. Referring back to our original hypothesis, we hypothesized that a higher mean years in school for women, ages 15 to 24, will correlate to a lower teen fertility rate. This is clearly seen and is proven true, as the correlation coefficient is a value of negative 0.688, and this represents a strong negative correlation, as it is above negative 1 and below negative 0.67. This provides justification of a trend that as the years of school for women increase, the teen fertility rate decreases at a linear rate. However, through this analysis alone, it is not enough to show a cause and effect relationship, as there could be other factors involved, such as a common variable. Looking at the equation of best fit, it can be used to predict where data points lie on the graph. For example, a country that averages 2 years of school for women, ages 15 to 24, should have about 116 births per 1,000 women ages 15 to 19, which is on par with countries such as Afghanistan and Burkina Faso. The reverse could also be found, where determining the number of mean years of school can be found through the number of births per 1,000 women ages 15 to 19. As I said previously, there could be another variable involved that is acting as an independent variable to both the variables we are looking at, which is called a common cause variable. For example, GDP per capita could be one of those hidden variables. How wealthy a country is can affect infant mortality rates, which means women will start having children earlier in life to be able to produce more. It can also affect how dependent countries are on agriculture, as countries with a low GDP will lack the infrastructure to develop other industries. This is especially seen with the outliers we saw earlier in the one variable statistics, with Mali, Democratic of the Congo, and Niger making up 35 to 40% of their GDP. Historically, countries that rely on agriculture have large families, meaning women need to start having children early in life. In addition, these countries also may lack contraceptive infrastructure due to less funding, and these countries will also lack the funding for public education, resulting in a lower mean years of schooling in total. The trend of GDP can be seen in this graph. The size of the point corresponds with the GDP of the country. The trend is that richer countries have a lower teen fertility rate and have a higher mean years of education for women ages 15 to 24. The trend is evident in the graph as the points are larger when the mean years in school increases and when the births decrease. Another variable that could be involved are conflicts. Temporary conflicts between countries or within countries may affect funding for education, as less funding will result in lower mean years of schooling. Birth rates are also affected, such as during wartime. The instability usually lowers the birth rate. Some other examples of conflicts could be famine, rebellions, and trade sanctions. And especially with rebellions, this is a common occurrence among African countries, such as within Mali, the Democratic Republic of the Congo, and Niger, which are all outliers in this data set. Another possible factor is gender inequality. In many countries, women are not offered the same chance of having an equal education as men. As a result, females are far less likely to enter the workforce, and in many societies, the societal norm for a female is to have a family once they reach a mature age. Another possible factor are people's values. People have different viewpoints which can impact the data. For example, communities that value education will have a higher average of schooling for females. Another factor could be societal norms. Cultures have different societal norms than others. For example, countries with lower marriageable rates will have more births from young women. Another factor could also be the infant mortality rate of the countries. Countries with a high infant mortality rate tend to have more teenage pregnancies as families want to start having kids earlier, as many of them will not survive. Looking back on the data collected, there is a strong negative correlation between mean years of schooling of women ages 15 to 24 and the teen fertility rate. So as countries have higher mean years of education, the teen fertility rate decreases. This confirms our hypothesis where we hypothesized that there would be a negative correlation between the variables. Now looking at our thoughts on the analysis, the results were shocking. I expected there to be a moderate trend, but not this strong, especially without removing the outliers. If we could redo this analysis again, I would find data that is more recent, as the data we collected was all the way back in 2010. I would also like to take a deeper focus on other dependent variables, as I found this very intriguing. And we could find the variables that are affected by the mean years of education for women, such as the number of females that enter the workforce per 1,000 women, the average earnings of women, and the age of women at their first marriage. Now, this concludes our presentation. Thanks for tuning in. This was Siobhan and Shantadani signing off. That's all, folks.